Hey everyone, our next unit of study is magnetic forces. Imagine zooming along Disney's monorail that glides without even touching the ground. You feel no vibration and hear no noise from the steel tracks below. You can just sit back and relax as you speed toward your destination. You are floating a few centimeters in the air on a magnetically levitating train. What makes it float? Believe it or not, it's magnetism. When you think of magnets, you might think about the objects that hold notes to your refrigerator. But magnets can also be found in many other day items, such as wallets, kitchen cabinets, and security tags at stores. A magnet is any material that attracts iron. Magnets have many modern uses, but they are not new. More than 2,000 years ago, people living in the ancient Greek city of Magnesia, what is now Turkey, discovered an unusual kind of rock. This kind of rock contained a mineral called magnetite. Both the word magnetite and the word magnet come from the name Magnesia. Rocks containing magnetite attract materials that contained iron. They also attract or repelled other magnetic rocks. Magnets have the same properties as magnetic rocks. Magnets attract iron and material that contain iron. Magnets attract or repel other magnets. And every magnet has a north pole and a south pole.
What happens if you bring two magnets together? The answer depends on how you hold the poles of the magnets. If you bring the north pole of one magnet near the south pole of another, the two unlike poles attract one another. However, if you bring two north poles together, the like poles move away from each other.
Why do you think that these two magnets were able to affect one another's movement, even when they were not touching? Pause the video and jot down your answer. The attraction or repulsion between magnetic poles is magnetic force. A force is a push or pull that can cause an object to move. A magnetic force is produced when magnetic poles interact. Any material that exerts a magnetic force is considered to be a magnet. Disney's monorail train that we talked about earlier depends on magnetic force to move. Magnets in both the bottom of the trail and in the guideway on the ground have the like poles facing each other. Because like poles repel, the two magnets move away from each other. The result is that the train car is lifted up or levitated. Other magnets make the train move forward. In some materials, such as iron, the north poles of groups of atoms can line up in the same direction in areas called magnetic domains. With each domain, the like poles of the atoms point in the same direction. So their magnetic fields are also aligned in the same direction. However, the poles of atoms in one domain may point in a different direction than the poles of atoms in another domain. Materials that form magnetic domains are called ferromagnetic materials. Iron and nickel and cobalt are examples. When a material with magnetic domain is exposed to a magnetic force, the magnetic domains become aligned, and the material temporarily becomes a magnet. This realignment causes iron to be attracted to magnets. Permanent magnets generate a net magnetic force because their magnetic domains always remain aligned. Draw it. Sketch how the magnetic domains of two iron nails might appear when they are near each other. Next, sketch how the magnetic domains of an iron nail might appear when placed near the north pole of a magnet. Use arrows to show the alignment of the magnetic domains, with the arrowheads representing the north pole.